Welcome to our lecture on security designs and security features, right? We're going to explore various aspects of security design for managing identities and access to understanding the importance of physical security. These concepts are crucial for safeguarding our network and ensuring only authorized users can access the resources. So by the end of this lesson, we should be able to explain identity and access management, distinguish different protocols for authentication and directory management, also implement defense in depth techniques, understand the network segmentation, and discuss how security implications affect IoT devices and industrial IoT devices. So you'll grasp the important concepts of physical security as well in a network. If you think about this, right, let's start by understanding what access control is. Access control involves four main components, right? So that is the identity management, where we identify a user, a device, identify a process like a username and password, a device ID, and all of that stuff. And then there is authentication, which proves the user or the device is who they claim to be. That includes passwords, biometrics, one-time passwords. Authorization, on the other hand, it determines what the user can access and what actions they could perform. The accounting, on the other hand, or auditing, this tracks the usage of resources, maintaining logs for activities, and monitoring processes. The authentication methods, if we take authentication in itself, right, these can be categorized into different categories. Some of the main ones are something the user knows, something the user has, something the user is, or something you are. When we say something you know, that is like a password or a PIN. Something you have, that would be a smart card or a token or an ID card. Something the user is or something you are is biometrics. That involves your fingerprint, your face ID, retina scans. Then there are other secondary categories called something you do, behavioral biometrics by typing in a pattern or a gate, somewhere you are, which includes stuff like geofencing to allow access only from certain locations. And we also have time restrictions, right, which fall under the category of somewhere you are or some when you are. Okay. Then we have different methods for authenticating, right? So there's the concept of single sign-on, where you just sign into one account and you have access to multiple different applications. That could be, it does not necessarily have to be from the same provider. It could be from several different providers, but you have like this portal where you log in and you could access several different applications. In order to this single sign-on to work, there's something called Kerberos, which is the protocol that is used to provide that single sign-on authentication. So they use more of a ticket form, right? So the tickets are used to authenticate users to the network. It involves a key distribution center, or KDC, that authenticates the user and issues ticket granted tickets, or TGTs. These tickets are then used to access services securely, like the applications and so on. As it relates to the authorization portion of it, when we deal with access control, right? Access control, and there are different models for access control, and one of them is discretionary access control, which pretty much means it's based on the user's discretion to give you access to a certain file or folder. So that's pretty much like if you have a Google file, a Google Drive file and you want to give access to, you want to share access to somebody. It's based on user. It's a user by user approach. The next approach or control model is called the role-based access control, or RBAC, which is based on specific roles within an organization. You're in marketing, you get that amount of permissions. You get this permission for that specific file. And there's also the possibility to combine some of these models, as there are more models that are also out there. The access management, or the terms that you definitely want to know, are privilege account. So a privilege account is an account with a significant permission. Privilege access management, or PAM, controls to provide abuse of that privilege account. So we want to make sure that there's a concept of the principle of least privilege, which pretty much grants the user only the permission that they need to do their jobs. There's also a concept called separation of duties, which pretty much divides tasks to prevent the misuse of the technologies and so on. One of the biggest concepts or is called defensive. When we deal with like hardening our services, when we deal with like making sure that our systems are protected, is defense in depth. And the defense in depth involves multiple layers of security to help protect against certain threats. When we have this layered approach, so we can have policies for policies, procedures, and awareness for users, education, and security policy. So with these different layers, if one layer was to be penetrated, there are other protection mechanisms at other layers to help secure our data and our devices and to protect our systems. So it involves physical security, involves which includes guards and locks and surveillance. It may involve perimeter security, where we have firewalls on the edges. We might have internal security, where we have segmentation and subnets, VLANs that we could help protect our systems. We also have host protection, where we have operating system hardening, patching, updates, BIOS passwords, and so on. But these are more the different layers of security. When we secure our switches, like specifically on the network, right? This plays a very crucial role in network security, as some of the key security practices have to be in place to ensure that only authorized people have access to our switches. And one of them is network access control, right? It authorizes only a specific set of people or specific set of devices, ensuring only authorized devices are able to connect to our switches. There's also port security, which secures the physical access to a port by using MAC filtering or even the different standards that you could use. There's also firmware updates that could be done, regularly updating your switch to fix any vulnerabilities on that switch and to protect against all of these different there's DHCP snooping that could also be used, or RA guard that you could also use. One of the other ones is something called the 802.1x. That's pretty much an authentication for devices before they're on network itself. It's all part of port security. For our security rules and so on, we might have for our network security rules. We might have firewalls, and firewalls, if you know what a firewall is, when we talk about in the previous chapters, it's to filter out traffic based on certain rules, right? And you could control access to the network using proxy servers to manage requests and enforce policies to improve your security and performance by caching or filtering out content based on these rules. You might also have what are known as content filtering firewalls, right? Or content filters. That involves more of like a protocol. You could filter out based on IP addresses, keywords to control the traffic. And firewalls and proxies use these criteria to allow or block specific types of traffic and enhance security. Some of the firewall if you have a firewall is only as good as how well you configure it, right? So if you one of the principles is if you have an overly permissive ACL that allows too much traffic, then we have problems. If you have overly prohibitive ACL, it may block the necessary traffic. But you also don't want to block all traffic if you don't configure the firewall properly. So you want to make sure that there's an implicit deny, so you're not blocking all unconfigured traffic, but you also want to make sure that you're not hindering security audits, and you want to make sure that there's the proper logging settings. So you want to make sure that it's set properly to help make sure that it's actually filtering out what it's supposed to be filtering. The next term in security is pretty much a categorization of the different parts of the network. And these are known as security zones. So you might have what are known as a private security network for sensitive data, very private. Then we might have private client networks for internal users and devices. You might also have guest networks for external visitors with very limited access to the network. The next one is a public server network, which is publicly accessible by servers, publicly accessible servers that are separated from our internal networks. One of the concepts when we zone out and we segment out, we create different zones in our network is something called a perimeter network or a screen subnet. This was formerly known as a DMZ, right? A demilitarized zone, which is pretty much a buffer zone between our internal private networks and our external and the external network like the internet and so on. But it's hosting public facing. So if you want to host like a public facing server or an email server, you might have to put this in that buffer zone to separate our internal network from our external threats. And this is probably going to use like an external router to help facilitate that screen subnet. Then we have the intrusion detection systems and intrusion prevention systems, IPS versus IDS. The IDS systems are pretty much there to monitor and to manage potential threats and alert when these threats are detected, whereas an IPS actively blocks them and ensures that there's a proactive stance in our network security. As it relates to the Internet of Things or IoT devices, there are a range of different devices, gadgets that we could that fall in that category, where they're not really computers, or they just other devices that require out that require the access to the network, right? So our Ring doorbell, our Google Nest Home, and all of these different devices, they need some sort of service. They provide some sort of efficiency, convenience, but they're also a security challenge. So we want to protect these devices and regularly update them, secure configurations, and ensure that they're on a segment within our network. So when we manage those devices, in order to manage IoT risk, we want to there's several different risk factors that actually affect these IoT devices, right? So we want to make sure that to manage the risk that's involved with these devices, we patch our systems regularly, we change any default configurations, and always include like security administrative interfaces, regularly audit our systems, isolate IoT devices and put them on separate network segments. This would help with from both the IoT devices, the regular IoT devices, and some of our industrial control systems that could be that still have to be managed in some sort of way, because most of these devices, they use up a lot of data, and that data has to be protected across the board. For network security, for the IoT devices like smart buildings and more of they fall into different categories. Like we see over here, you might have consumer grade stuff and more of like the enterprise level stuff, which pretty much but they still have to be protected in the same format. Maybe in an enterprise level it has to be protected even more, but most of the consumer grade stuff has to be. There are several vulnerabilities that require some patch management or changes within the systems itself. The final thing that we want to go over is physical security, which is pretty much our first line of defense, where if we have unauthorized access, this could lead to data breaches and hardware theft. So when we mitigate against these using physical security, mitigate against these threats using physical security, we're able to control access to our systems, surveil our systems, and regularly update our systems. This would wrap up the topic of security concept, security with zone-based security, or just security designs and features on our network.